So defining logs again, a log, here's your log. A log is just an exponent. It's another way to write an exponential expression. That's all a logarithm is. Kind of like the square root of 5 is just a way to think about the undoing of squaring something. What's the square root of 5? Well, it's somewhere between 2 and 3. The square root of 5 is somewhere in between 2 and 3. It's the number. How do I know it's between 2 and 3? Because the square root of 4 is 2, and the square root of 9 is 3. And so the square root of 5 is somewhere between the square root of 4 and the square root of 9. Okay? So what is a logarithm? Well, the log base 3 of 9 just means 3 to what power equals 9. That's what that means. Well, that would be 2, because 3 to the second power equals 9. So what's the log base 5 of 10? Well, that's just saying 5 to what power equals 10. That's what you're saying. 5 to what power equals 10? And the answer to that isn't a nice number. It's not a whole number. It's not even a rational number. It's an irrational number. It's a number somewhere between what? Well, you know that 5 to the first power is 5. And you know 5 to the second power is 25. So what's the log base 5 of 10? It's somewhere between 1 and 2, because it's whatever power you raise 5 to get 10, which is like 1 point something. So you can punch that into your calculator. By the way you can tell what that is, if you take your calculator and you punch this in, that's the change of base formula. If you punch in the log of 10 over the log of 5, if you punch that in, log of 10 over log of 5, you just change the base to log base 10, because your calculator knows the log base 10. It doesn't know log base 5. You have to convert it. So log base 10, or log of 10 over log of 5, punch that in and tell me what you get, which is approximately 1.4. So the log base 5 of 10 is approximately 1.4. That means that 5 to the 1.4 is going to equal 10, or approximately 10. And that's what a logarithm is all about. So logarithms were created so you could solve problems like this. 3 to the x plus 2 equals 15. Because before you learned logarithms, to solve a problem like this, you would have to do this. 3 to the x equals 13. And then you would have to do what's called extrapolating. You would have to try to find a number that works. You'd have to say, well, it's somewhere between 3 and 4. Somewhere between 2 and 3. It's somewhere between 2 and 3. Because 3 squared is 9 and 3 cubed is 27. And it's closer to that. So it's probably somewhere between 2 and, let's guess, 2.2. So you would punch in 2.2 in your calculator, 3 to the 2.2, and see if it's higher than 13. If it was higher than 13, then you would go over to this side and you would find something over here. You'd say, you're basically just guessing and checking until you get like as close as you can. Then you could, like, if you said it was between 2.2 and 2.3, then you would try 2.25, and you would see if it's closer. You know what I'm saying? You would just extrapolate it. It took forever to do. So what they decided is someone came up with logarithms. And logarithm is just a table of values. That's all it is. And that table of values, your calculator has 2 table of values in it. It has log base 10 values in it, and it has log base e values, which is ln, the natural log. So here's what exponents, or here's what logarithms allow you to do for this problem. It allows you just to take your calculator and rewrite this as a logarithmic equation. You would say log base 3 of 13 equals x. And now, that's just a change of base formula. It's the log of 13 over the log of 3. punch it into your calculator, and you'll get the exact answer for it. You don't have to do any extrapolating.